The next video in the counting methods series is on arrangements. So given a set of objects, how many different ways could they be arranged in a line? So thinking about three people lining up in a queue, in how many different ways can that be done? So here's our three people. We could keep the red man at the beginning and swap the other two people. We could then look at putting the blue lady at the beginning and swap the two men around, and then look at having the yellow man at the beginning and swapping the other two around. And so through a systematic approach we can work out that there are 6 different ways that the three people can line up. Okay, so what about 4 then? So here's our 4 people. So we know that those 3 people can line up in 6 different ways. We've just worked that out. So that means that there's 6 arrangements where the red man is first. Then we could put the blue lady first, and again there's 6 different ways the other 3 could line up, so 6 arrangements with the blue lady first. Again, there would be 6 arrangements with the yellow man first, and 6 arrangements with the green lady first. So either the red man is first, or the blue lady is first, or the yellow man is first, or the green lady is first. And so we have a situation where we're adding the options, and so we're looking at 6 plus 6 plus 6 plus 6, so 24 different ways that 4 people can line up in a queue. Okay, so what about 5 people? So again, same kind of logic. If we think about the 5 people, we know that there are 24 different ways for 4 people to line up. So that means that there are 24 different ways where the red man comes first. And we can use similar logic to extrapolate that there'd be 24 ways in which the blue lady could line up first, 24 ways in which the yellow man could line up first, etc. So there is going to be 5 lots of 24, so 120 different ways that 5 people can line up in a queue. Okay, but what about if we then jumped ahead to 20 people? Obviously the examples we've looked at previously, we've been able to work out the number of arrangements for 4 people fairly efficiently because we knew about how many ways 3 people could line up. And similarly we could work out the number of ways 5 people could line up fairly efficiently, knowing how many ways 4 people could line up. But if we just jump ahead and say, well, how many different ways can 20 people line up, or how many different ways can 100 people line up, then we need to think a little bit differently. So a sort of pigeonholing technique is often useful in these kinds of problems. So if I imagine here's my queue with 20 spots available in it, and I think about, okay, so the first spot in the queue, I've got 20 people available to fit into these 20 spots. I'm trying to work out how many different ways they can do that. So if I think about, well, okay, there's 20 different people that could stand in the first spot in the queue. And then once I've put someone in the first spot, there are 19 people remaining who I can choose from to put into the second spot in the queue. And then there are 18 people remaining to fill the third spot, 17 people remaining to fill the fourth spot, and etc. And so we can work our way down the line thinking about how many options are there for this position. Now, we also know that we want to have someone in both the first position and the second position and the third position, etc. So this is a multiplication situation. So we want to multiply those options together. And so the number of different arrangements is going to be 20 times 19 times 18 times 17 all the way down to 1. Now we have a shorthand notation for that kind of multiplication, and that is 20 factorial. So the exclamation mark is factorial, and 20 factorial, or anything factorial, simply means you multiply that number and then you keep subtracting 1 from that number, multiplying them all together until you get down to 1. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1. So to access factorials on your CAS, you're going to type the number 20 or type whatever number you're trying to work out the factorial of first, and then press menu 5.1, which is menu probability factorial, and you will obtain the answer. So as you'll see, as we increase the number of things we're trying to arrange, the number of possible arrangements increases quite rapidly. Okay, so arrangements. The number of ways to arrange n objects in a row is given by n factorial, where n factorial is n times n minus 1 times n minus 2 all the way down to 1. And again, factorials on your CAS menu 5.1. Okay, so let's have a look at some examples. In how many ways are there to arrange 7 soldiers in a line? So we could set up 7 little pigeonholes and think it through, but simply arranging 7 objects in a line, we know that that is going to be 7 factorial. And so if I go to my CAS, 7 menu 5.1, that is 5,040 different ways that the soldiers can line up. Okay, then we suppose that there are 6 privates and 1 corporal making up these 7 soldiers. So in how many ways can the soldiers be arranged so that the corporal is at the head of the line? Okay, so this time you want to think, alright, I've got my 7 spots, and you might not need to draw them all out. You might be able to think this through in your head. So the corporal has to go at the beginning of the line, so there's only one person that can go in the first box. And then I have 6 people left, any of them could go here, 5 people left, any could go here, 4, 3, 2, 1. We need someone in each of the 7 positions, so it's an AND problem. And multiplying 1 times 6 times 5 times 4 times 3 times 2 times 1, or we've got 1 times 6 factorial there, and 6 factorial is 720. So 720 different ways the soldiers can line up if the corporal has to be at the beginning. Okay, here's just some playing around with factorials. So simplify and evaluate 10 factorial divided by 8 factorial. The intention here is not for you to go for your CAS, it's to think about what these factorials mean. So we know that 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we know that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so what we see here is that in dividing 2 factorials, we're going to get, particularly in this case because the denominator, the factorial on the denominator is smaller than the factorial on the numerator, we're going to end up with the entire denominator cancelling with part of the factorial on the numerator. And so all we're actually going to be left with here is 10 times 9, which is 90. Part B is asking you to work in the reverse, so write 22 times 21 times 20 times 19 as a quotient of 2 factorials. So quotient means division. So we essentially want to write something similar to the expression we were given in Part A to represent 22 times 21 times 20 times 19. So obviously we know that 22 factorial is 22 times 21 times 20 times 19 times 18 times 17 times So we want the beginning of that, but we want to get rid of the 18 and below. So that means we're going to need to divide this by 18 factorial, so that we're going to be dividing by 18 times 17 times and that's all going to cancel out. So 22 factorial divided by 18 factorial is 22 times 21 times 20 times 19. Okay, so now we think about perhaps not trying to arrange all of the group. So this time we've got a group of 10 people and only 4 chairs. So we want to think about how many different ways we can fill the 4 chairs. So again, a sort of pigeonholing technique is useful here. So I imagine that I've got 4 spots, 10 people available, so how many people can I put in the first chair? I've got a choice of 10. And I also need someone in the second chair, so it's going to be multiplication. And there are 9 people, 9 choices I've got left for the second chair. 8 choices left for the third chair, 7 choices left for the fourth chair. As I said, we're multiplying because it's an AND problem. And 10 times 9 times 8 times 7 is 5,040. Okay, so there's a couple of different ways that we can work this out. I would say that this method we've just done here is the most straightforward and the easiest, and generally that's what I would use each time. There are some other ways we can do that though, and in fact 10p4, which is a new notation, 10p4 is going to represent this same calculation. So P stands for permutations, and permutations is just another word for arrangements. So to permute is to arrange, so the number of permutations or the number of arrangements is the same thing. So this is saying we've got 10 things that we want to permute or arrange into 4 positions. And there's we can get to that immediately from your CAS. I'm sure I'll mention it further on in the video, but I think it is menu 5.2. So menu probability permutations should bring this up. So this is equal to 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial, which is exactly the calculation that we're trying to do here, 10 times 9 times 8 times 7. And so it gives us 5040. So to work out a problem like this, you could set up the boxes and think about, right, I'm going to have 10 times 9 times 8 times 7 and calculate that. You could immediately go to 10 factorial over 10 minus 4 factorial, or you might, if you've got your calculator, use 10p4 straight away. So the number of ways to arrange n objects in R positions is given by npr, which is n factorial over n minus r factorial. Okay, so let's look at some examples again. So in a squad of 12 athletes, 3 different athletes must be selected for 3 events, the 100 metres, the 200 metres and the 400 metres at the weekend competition. In how many ways can the athletes be selected for the events? Okay, so we've got 3 different events to which to allocate 12 athletes. So we'll do this a couple of ways. So the first thing is you can think, okay, I've got my 3 events. There are 12 athletes that could enter the first event. I then have only 11 athletes left to fill the second event because I need to choose 3 different athletes, and 10 athletes left for the third event. We want someone in all 3 events, so we want 12 times 11 times 10, which gives us 1320. So that's the number of different ways we could choose 3 athletes out of the team. The other way that you could do this is to straight away say, well, I've got 12 things that I want to arrange into 3 positions. We can go straight to our CAS here. That would be menu 5.2. And when you press menu 5.2, it brings up NPR with a bracket, and you need to put your 12,3 in here. And immediately that should give us 1320. The third way is you might go straight to, well, I'm going to have 12 factorial over 12 minus 3 factorial, which is 12 factorial over 9 factorial, which is going to be 12 times 11 times 10, which is going to be 1320. Okay, a coachload of 56 senior citizens arrives at the theatre for a matinee performance. In how many different ways could the 15-seat front row be filled? Okay, so we've got 15 seats to fill with 56 people. So this is where it's going to start to become a bit tedious to set up boxes and try and sort of think that through. Essentially, you're going to need to do 56 times 55 times 54 times 53. You're going to need to multiply 15 numbers together. So this is certainly where at least understanding that NPR does the same thing is a quicker way to go about this. So we want to arrange 56 senior citizens into 15 positions. So I'm going to go straight to my CAS with that rather than write out a lengthy multiplication. And we actually find that it's quite an extraordinary answer. 2125397676037888595. 2, 1, 2, 3, 4 zeros at the end. So there are that many different ways to arrange. So again, these kinds of problems we see as we increase the numbers, even just fairly modestly, the number of different arrangements that start to occur increases very, very rapidly. Okay, so in summary, the number of ways to arrange n objects in a row is given by n factorial, where n factorial is n times n minus 1 times n minus 2, multiplying all the integers down to 1. Factorials are obtained with your CAS by pressing menu 5.1. The number of ways to arrange n objects in R positions is given by NPR, which is n factorial over n minus r factorial, and NPR can be obtained by pressing menu 5.2 on your CAS.